All right. So my name is Nicholas Rosmatos. I'm CCSP, which is a cloud-certified service provider, tech evangelist with Red Hat, which is basically just a really fancy way of saying I'm a nerd who likes to play with emerging tech. So hopefully you're here to learn a little about storage, specifically with containers. So I'll talk a little bit about it, and then I'm just going to go straight into some demo stuff, because I'm sure people would rather see demos than a bunch of slideware. So quick little recap. Everybody here knows a little bit about containers versus virtualization, why you use one versus the other. Virtual machine is basically a full-blown operating system. Container abstracts the kernel operating system. Containers are really great when you're talking about hundreds of thousands, and virtual machines, usually you're talking about tens of hundreds in most infrastructures. And the benefits of containers, obviously, are higher quality software releases, shorter test cycles, and easier application management. So a developer can go hack together an application on their own laptop, push it to a registry, and then start deploying it to production or staging or development environments that are hosted either in your own data center or within the cloud. So why do containers need storage, right? When most people think of containers, they think of ephemeral or non-persistent workloads. And actually, that's not true at all. Especially with OpenShift, we see a lot of our customers that are taking legacy applications that they're running in their own data centers, and as they're moving things into the cloud or into hybrid deployments, they're actually wanting to basically modernize these applications, move them into a container, and then deploy them into these infrastructures. And so why is container storage a pain point, right? A lot of people, they're using a one-to-one relationship where they're taking a disk and they're mounting it to their container host or their container node, and those containers are actually consuming that storage. And that works great on a small scale, but when you're looking at distributed applications, or when you're actually trying to scale out, and you need to do read, write, many, it doesn't actually work the way that we would like it to, right? Unless you're using some type of storage appliance or some type of network file system. And even then, there's a lot of complications. And to further that, really, you need advanced storage capabilities. Your developers don't want to go in and have to put in a request to go get storage. They want to request storage on the fly when they're actually deploying these containers, when they're building these applications out. They shouldn't have to, the usual process of turning in a request, storage team provisions the storage, you get the email back, now suddenly they're deploying an application to it. They should just be able to consume on the fly, and you can set quotas and manage these things in a different methodology. So really self-service, in a sense, for storage. And it was interesting, so this was a survey that was done. It's a little outdated, a couple years old, but I thought it was really interesting because when we think of workloads, at least those who are dealing with containers on a pretty consistent basis, we think of ephemeral, and that's not the way that Fortune 500 see it, right? They're thinking of data applications, cloud-based applications, systems of record. These are all persistent-based applications. These aren't just stateless applications that are completely transient. These are applications that require some type of persistence, whether it's a database or some type of middleware layer. And when you think of storage options for containers, really what do you have, right? So if you're in your own data center, you think of appliances for the most part, right? So you're thinking of black box hardware, maybe it's EMC, maybe it's NetApp, whatever it is. Which kind of has its own type of lock-in because you can't go with white box hardware. And if you ever decide that you want to migrate, you're talking about migrate large amounts of storage. And that doesn't really play well also when you're looking at cloud. So a lot of customers are looking at hybrid cloud or moving all their stuff into Azure. And so that doesn't really play the same way. And for the most part, you want portability, and you want the same type of abstraction layer. So it doesn't matter if you're running this stuff in Azure, if you're running it in your own data center, the way that you should be consuming your storage should be consistent, the same, regardless of where it is. You shouldn't have to use different tooling, different methodologies. Your operations team shouldn't have to have different ways of supporting these things. So if you look, we've moved from like waterfall and agile to DevOps and microservices and containerization to hybrid cloud, and we're moving to storage as a service. But why is it, for the most part, that storage hasn't really evolved? Right? Storage seems like it's this archaic design for the most part. It's really not thought-leading. Even the big companies are really kind of slow adopting some of these like storage as a service or software-defined storage solutions. And so we actually wanted to solve some of these problems. So when you think of containers, as I mentioned, you think of two kinds of storage. Persistent storage, right? So if the container dies and respawns, or if you actually deploy multiple, that storage persists regardless. And then you think of ephemeral, right? Non-persistent. And really, like from a developer perspective, they want to be able to write their code, abstract it, build it, push the image to a registry, deploy that registry, whether it's a test or a production environment, and they want it to just consume whatever it is and whatever those dependencies are on the fly. It's the reason why we're moving towards containerization, right? We don't have to build these big monolithic virtual machines that we deploy. We could build these really lightweight containers that we could spawn up in a matter of seconds, and we could actually scale those in a matter of seconds and get better control and ROI of our infrastructure. So that's where we really started coming up with container native storage. So in this example, we're going to have a combination of fast pool and slow pool. There's going to be 3 nodes that are actually persisted with storage. There's going to be other nodes that have no storage, but they're consuming that storage. So you're not actually landlocked in a sense. You're not isolated to running containers that need persistent storage, specifically on nodes that are backed by storage. And this is kind of a little bit of how like the OpenShift persistent storage system works. And I shouldn't just say container native storage is for OpenShift. Yes, it's great, but it's actually spawned from the project Hiketi or Argo, which actually ties into some of the Kubernetes CLI. So Hiketi CLI integrates directly into the cluster file system. So a developer can request a persistent volume. They request their storage class. Their operations team has already set up this infrastructure. Their application instructs the cluster on the back end and says, I need storage. It needs to be this speed or class or volume type. And then it gets provisioned and the pods consume it. So how does OpenShift request it? Well, OpenShift talks to Hiketi through a RESTful API. That's actually in the storage class object, and I'll show you a little bit about Hiketi. And then Hiketi actually provisions the volume and handles all of the abstraction for the application and the pods. And then obviously storage class use and definition. So there's a little bit of YAML in here that shows you a little bit about it, but specifically in your container native storage, when you're actually requesting it, you can define whatever the storage class that you need. So that could be the number of replicas, that could be performance driven, that could be geolocation driven. There's a number of variables that you can actually configure it for. So container ready storage, as I mentioned, it's a little bit different than container native storage. Container ready storage means basically you have Gluster that's persisted on the back end. You're not actually hyper-converging the storage alongside your nodes that are actually running your containers. So it's really good to have that flexibility to have both container native storage and container ready storage that you can consume in either way. So container native storage, as I mentioned, in this example, we have an OpenShift node that's running Elasticsearch. It's actually completely stateless. We have these Nginx containers that are consuming Gluster. Those are actually coming from nodes that are backed by storage. And then we actually have nodes that all they're doing is serving out storage. So really, you could expand it and carve it out any way you want. You could have nodes that are hyper-converged. You could have nodes that are completely stateless. You could have nodes that are consuming storage on the fly. However you want to configure it, it's completely up to you, right? You could do unified orchestration and do hyper-convergence so you get better ROI and density in the cloud, so you're not actually having to spin up standalone storage nodes. Or you can configure it so that your storage is completely segmented or separated. So I'm just going to go straight in and jump straight into it because we don't have a ton of time and I'd rather show more than less. So if we do Hiketi CLI, can everybody see that? Should I expand it? It's good? OK. So this is a cluster list. We actually see our Hiketi cluster that's providing file and block storage. And if we go in and we do a topology, we can actually see all the information from Hiketi. So specifically here, we're seeing that there's the hostname mycluster CNS1, which is backed by multiple disks. And all those disks are actually provisioned and participating in that Gluster storage. If we, in OpenShift, go to storage classes, you can see that we have both Azure standard storage, and then we have the Gluster file system storage, which is the design that actually has 3 replicas by default is the way that I actually built it. And if we look at the Azure portal, this is all of our infrastructure. So for example, those nodes, you can see actually that there's multiple disks that are being provisioned and persisted behind the actual nodes themselves. So let's go ahead and let's create a project. So we'll do OC new project, and let's just call it Ignite. So the great thing about OpenShift, obviously, is you have the ability to view things from multiple different ways. You could actually go through the user interface, or if you want, you could actually go through CLI for everything. It's completely up to you, depending on however you want to actually deploy your things. So we'll take a look and we'll see that there's no persistent volumes right now except for the stuff that we have bound to the Azure storage. This is specifically handling logging, so that would be like Prometheus and such, and then our actual container registry. So let's deploy an app. Here, I'll cat to this real quick so that you can actually see what we're going to do. So all we're doing is OC new app. We're specifying OpenShift. We're actually pulling this from GitHub, so you can actually go out there and you can pull this down yourself if you want. And then we're giving it a name, file uploader. So app is provisioned. We go over here. We can actually see that the app itself is getting ready to actually be built out. We see that our build is running. We can take a look at our logs, and as soon as the pod comes up, we'll actually be able to start tracing those logs. Oops. Go see get pods. -O wide. So if we grab this guy, we can actually do OC logs-f. And we can actually see that it's pulling the image, pushing it to the Docker registry, and then actually provisioning the pods themselves. And when we expand this out, we'll see this pod actually created once it finishes doing its Docker pull. And over here, we see our pod coming up, and you can actually see the logs that are being persisted. So next thing we need to do is we need to be able to make this routable, right? Because by default, whenever you create a pod, it actually is not accessible. It's only accessible internally within the cluster. Question? Oh. So we're going to do an OC expose, and then we're going to expose the service. So for those that aren't familiar, when you create a new application, it actually creates a service. The service is responsible for the load balancing and handling the API calls that you're actually doing for the pod itself. So right now, as I mentioned, this pod is up and running, but it's not accessible. So we can actually take a look at it. We can do an LS. We can actually see the information on it. So we're going to expose it. And OpenShift creates a route, right? So we actually can see our application itself, but right now this doesn't have any persistent storage. So if you go back in and you look at the pod itself, or if you look at the application itself and look at the configuration, you can see that there's no volumes that are actually created for storage. So what we're going to do now is we're going to add storage. And really all we're doing is OC set volume, and then we're specifying the file uploader, and then saying add storage and configuring the storage itself. What OpenShift is doing now is it's building out a new pod, and it's actually mounting that volume specifically to that pod. So now that pod is actually going to have persistent storage. So if we go back here and we do OC get PV, oops, you can see that there's a new persistent volume that's been created, and that's actually mapped. So now if we take a look at this pod, and we go into the terminal itself, oops, we'd actually see that there's a directory called uploaded, but there's nothing in there, right? So let's go ahead and add something real quick. And hopefully our network's not as terrible as it was earlier. Let's hope. Still uploading, ever so slowly. All right, we'll just have to grab another image. Throw this on the desktop. So the idea is that we can actually go here, go to our desktop, take a look at the file, upload the file real quick. Now it's sitting in there, right? If we do a list of the upload files, we can actually see the file that we just uploaded. We can click on it, and we can see it. If we go back into the terminal session, we can see that the file is there now. But what happens when you need to scale up your application, right? Let's go ahead and scale it up to 4 pods. OpenShift handles the scaling, handles the mounting of all of the storage on the back end, persists all of that storage. There's no downtime within the application itself. And if we grab any of these actual pods, so let's go here, let's grab any pod. Let's grab this guy. If I could type, we can actually see that that file is actually accessible by all of the pods now. So why does this matter? Well, let's just assume you have a catastrophic failure and you lose all of your nodes. So let's take a look at the nodes real quick, right? So these individual nodes actually have persistent storage that are allocated to them. These nodes are actually consuming some of that storage. Pods can either land here or here. Wherever we actually have it set up for scheduling is wherever a pod can actually run. If we didn't want pods to be run there, we would actually just disable the scheduling on it. So if we take a look at the pods themselves, you can actually see we have some of those pods. The first two are actually running on the container native storage. So they're actually on the hyper-converged nodes. And then these other pods are actually running on nodes that have no persistent storage backing them whatsoever. They're consuming from the other storage cluster. So if I wanted to actually disable one of these nodes or just simulate failures and shut them down, nothing would happen to the application. It would just actually start pulling data from a different replica for the cluster. And if you scale out, as the pods scale out, so even if we wanted to, let's say we just scale out to, I don't know, 8 pods, right? Not a big deal. OpenShift handles all of the load balancing on the back end. It configures HA proxy. It spins up the pods and mounts all of those individual volumes. Now if we take a look, finishes its load balancing and distribution of all of the individual nodes across all of the infrastructure that's actually being scheduled. And then obviously, let's say you scale all of your nodes down to nothing. You've now essentially killed off all of your containers that are actually running in that infrastructure. There's no pods that are mounting any of that data. Your application is obviously down, so it's not going to work. But let's just assume, let's say you had a catastrophic failure for one reason or another. As soon as your pods come back online, they're going to mount that volume all over again. Your application is going to start picking up all of that data again. Your files are still safe, right? So all of your storage is being persisted, regardless of how you're actually architecting it. And this could be on Azure Stack, this could be on your VMware infrastructure in your own data center, this could be in Azure, this could be multi-cloud. It doesn't really matter. It's completely abstracted. It could be on white box hardware, it could be on whatever you decide to choose to deploy it to. We have a lot of customers that are actually deploying infrastructure into Azure. They're doing a lot of hybrid stuff. We're working on trying to get federation so that you could have OpenShift clusters running across multiple different cloud providers and actually have it all abstracted away so that it just looks like different regions or availability zone sets. But yeah, that's pretty much it in a nutshell. Questions? No? So a quick little plug I'll do. If you guys actually want to take a look at OpenShift and get some hands-on experience for free, we don't need all that. You can actually go to this link. We have 8 hours of complimentary labs. You could go on there, you could jump. Basically, it's a multi-node OCP deployment. It has container native storage backing it. You have full access to all of those nodes. So you have complete root access. You could destroy the environment if you want. You could deploy whatever you want to that environment. It's really to get you some hands-on knowledge. It is like guided in a sense where it walks you through different scenarios if you don't have scenarios that you want to bring. But if you have your own application and you're like, well, I want to kind of test this, you could do that. Or if you reach out to me, we're actually dealing with Microsoft in a sense where we actually give OCP evaluation subscriptions, and then we can actually give you an allocation of funds to run your applications on Azure and an OpenShift cluster. So we basically put those funds in your subscription, and you can actually deploy OpenShift and do a proof of concept on it. Yeah, so if anybody has any other questions, feel free to let me know. Otherwise, have a great conference.